Hello and welcome back to Info Index. Today I will be teaching you about linear relations, specifically the slope y-intercept form of expressing the linear relation. Linear equations have three major forms: standard form, point slope form, and slope y-intercept form. These each have different uses and advantages. Now, what is a linear relation? Well, a linear relation is a term used to describe a straight line relationship between two variables, usually x and y. As x keeps increasing by a constant interval, y increases by a constant number each time. This means that the graph of the relation would be a straight line. A linear graph is on a Cartesian plane, which looks like this. The x-axis is the horizontal one and the y-axis is the vertical one. A slope y-intercept equation is in the form of y equals mx plus b, where x is the independent variable and y is the dependent variable. M is the slope of the graph. The slope of the graph is basically how much y changes if x increases by 1. It can be found by dividing the change in y by the change in x, or y2 minus y1 divided by x2 minus x1. You can easily remember this by slope is equal to rise over run, where rise is how much the graph rises, which is the change in y, and run is how far horizontally the graph changes, or the change in x. The y-intercept is b. The y-intercept is the y value when the graph passes the y-axis. This also means what is the y value when x is equal to 0. An equation in the form of slope y-intercept is easy to graph. Even if the equation is not in slope y-intercept form, it is still easy to put into the slope y-intercept form by isolating for the y variable. For example, 3y plus 6x equals 5. 3y is equal to negative 6x plus 5. Y is equal to negative 2x plus 5 over 3. Now let's try graphing this equation here. Y equals 2x plus 3. To graph this equation, we first start off with the y-intercept. Remember, the y-intercept is the value of b in the equation. You plot a point on the y-axis with the same value of b. The y-intercept in this case is 3, so we put a point at 0, 3. Now, we use the slope. The slope is the coefficient of x. In this case, it is 2. This means every time x increases by 1, y increases by 2, and every time x decreases by 1, y decreases by 2. From the point that we first plotted, we increased x by 1, and so y will increase by 2. The new point would be 1, 5. We can check if this is right by subbing in the point back into the equation. X is 1 and y is 5. When we put it into the equation, we see that both sides are equal to 5, so it is correct. You only need 2 points in order to draw a linear relation. We now connect the 2 points and extend it past the points. We then draw arrows at the ends of the line to indicate that the line goes on forever. If we are given a linear graph, getting the slope y-intercept equation is also easy. We first write down the general equation y equals mx plus b. We must first find the slope. To do this, we need to find 2 good points on the graph. This means that the points have x and y values that are clear on the graph, and they are not in between the marked values. In this example, 2 good points are negative 1, 5, and 3, negative 2. The slope is equal to rise over run, or y2 minus y1 divided by x2 minus x1. We choose one of the points to be 1, and the other point will be point 2. y1 is the y value of the first point, x1 is the x value of the first point, and y2, x2 are the y and x values of the second point respectively. If we choose negative 1, 5 to be point 1 and 3, negative 2 to be point 2, then the slope is negative 2 minus 5 divided by 3 minus negative 1, or negative 7 over 4. And vice versa, if we choose 3, negative 2 to be point 1 and the other to be point 2, the result would be the same. 5 minus negative 2 divided by negative 1 minus 3 is still equal to negative 7 over 4. We can substitute this value in for m in the equation, so it becomes y equals negative 7 over 4x plus b. Now to find the y-intercept, If the point where the graph passes the y-axis is clear, then we can just take that y value as our b. However, if there is no clear point, then we can find it algebraically. We can use one of the clear points from earlier and substitute it back into the equation. If we take -1, 5 and put it back into the equation, it becomes 5 is equal to -7/4 times -1 plus b. If we solve for b, we get b equals 13/4. Now we have the slope y-intercept equation, y equals -7/4x plus 13/4. I hope you all learned a lot in today's video, and please like and subscribe for more future content.